Okay, so in this presentation, we're going to do arithmetic sums. And when we use the word arithmetic, that implies that we are dealing with linear models. So we just want to have those two words linked together, those two phrases. And if we look at the textbook's definition of an arithmetic sum, it says that if we are adding n consecutive terms of an arithmetic sequence, again, when we say arithmetic, that means that the terms of the sequence are from a linear growth model. So once we've identified we're adding up the terms of a linear growth model or an arithmetic sequence, we have a formula for calculating the sum. So it says a sub 0, which we should understand is the first term. We call that the initial population or the initial term. A sub n minus 1, that's the last term. And there's a relationship here that the subscript is 1 less than the number of terms, because the number of terms is n. Subscript of last term is 1 less than the number of terms. So let's see this in action. Let's look at our first example. Example 1 says we're going to find the arithmetic sum from a list, and it says to evaluate the sum of 3 plus 6 plus 9 all the way up to 126. So the first thing that we look at here is that are we dealing with a linear model? And because every term is increasing by the same amount, we have a common difference, and the common difference is 3. That means that we can write the linear model for this. P sub n is equal to the initial population is 3, plus it's changing by 3 per term, so 3 plus 3n. We know that P0 is equal to 3, but what's the subscript of 126? We need to solve for n. Let 126 be equal to 3 plus 3n. Notice we took that from our model, and we're going to solve for n. So we subtract 3 from both sides. 123 is equal to 3n. If you divide both sides by 3, you get that 41 is equal to n. That means that P subscript 41 is equal to 126. Now that we know the subscript of 126, we know how many terms we have here. I'm going to go back to the previous slide. Remember, we said that the subscript is 1 less than the number of terms. So if our subscript is 41, that means we have 42 terms if you start counting from 0. From 0 to 41 is 42 terms. And if we were just to count from 0, 1, 2, 3, 4, 5, you can see that from 0 to 5 is 6 terms. So it makes sense that from 0 to 41 is 42 terms. So now our formula says that the sum is equal to the first term added to the last term. 3 plus 126 is 129. Multiply that by the number of terms, 42, and divide everything by 2. Again, let's look back at the formula. First term, last term are added, number of terms, and everything divided by 2. So after we work this out, we get 2,709. So why does this formula work? Well, let's look at a popular example. It's a classic example with arithmetic sums. Let me just insert a blank slide here. If you wanted to add all of the numbers from 1 to 100, you say, well, I can do that. It's just going to take me a while. But if we start to look at this differently, we might be able to do it quickly and come up with this formula. What happens when you add the first number to the last number here? 1 plus 100 is 101. What happens when you add the second number to the second to last number? What is 2 plus 99 equal to? 101. What happens when you add the third number to the third from the last number? 3 plus 98 gives us 101. So we're getting the sum of the first and last number multiple times. So that should make sense of the first part of our formula, that we're adding the first and last term together. Well, first plus last terms. Well, if I have 100 numbers here and I put them in groups of 2s, how many times can I get a group of 2 from 100 numbers? And you should say, well, 100 is the number of terms because we're starting counting from 1 and we're going to 100. That's 100 terms. We're taking 2 at a time. That gives us 50. So basically, we're saying the number of terms divided by 2 is what we want to multiply this by, and we'll get the sum. So we just came up with the formula that we used in the last example. Now, the only difference here is we start counting from 1, and our population models start counting from a subscript of 0. So the number of terms is just 1 more than what we would have. And again, the difference is we're starting our counting from 1 in this example, and the population models start counting from a subscript of 0. So if I were to give you another example where P0 is equal to 2 and P10 is equal to 32, we can say that the formula is Pn equals 2 plus 3n. If I plugged in 10 for n, we would get 32. So from 0 to 10 is how many terms? And you should always write this out. From P0 to P10 equals 11 terms, and that is just to acknowledge that we're starting our counting from a subscript of 0, from a label of 0. So that's going to be 11 terms. If we started counting from 1, if it was P1 to P10, it would be 10 terms. So part of our task is to pay attention to where we start counting from. So if I wanted to add up all of these numbers from P0 to P10, the first term plus the last term 2 plus 32 times the number of terms, 11, divided by 2, because we have to take them in pairs of 2 at a time, and we would be able to come up with our answer here. 34 times 11 over 2 gives us 187. So we did 2 examples like that. Let's look at another case. Here, example 2 says that we're going to find the arithmetic sum from a formula. And it says find the sum of the first 50 terms, starting with p sub 0 equals 150. Well, p sub 0 through p what is going to be 50 terms. Remember, you have to consider that off by 1 in counting. So P0 through P49 is equal to 50 terms. That means this is our first term, this is our last term, and we need to calculate what is P49. So we come back here and we say P49 is equal to 150 minus 2 times 49. P49 150 minus 2 times 49 gives us 52. So that means our sum is the first term, which is 150, plus the last term, which is 52, times the number of terms, which is 50, all divided by 2. I can say that 2 cancels into 50, which gives me 25. And if I add these two, 150 plus 52 is 202 times 25. 202 times 25 is 5,050. And one last example, just to show you a different way the question can be asked. Suppose that a population grows following a linear growth model. Once we read that, we know that our formula is P sub n equals P0 plus the common difference times n, which is the subscript of the term. We know that P0 is 11, so I can update my formula for Pn is equal to 11 plus, from P0 to P1, that difference is 6, so my common difference is 6 times n, so I have my formula now. And it wants me to go from P20 through P55. So we need to calculate the values for each of these. P20 is equal to 11 plus 6 times 20. 6 times 20 is 120, plus 11 is 131. And now P55 equals 11 plus 6 times 55 equals 11 plus 6 times 55, 341. So the sum is equal to 131 plus 341. That is the first plus the last. Now we need the number of terms. 55 minus 20 is 35, but we always have to add 1 extra for the starting term, so there's 36 terms. 36 terms divided by 2, and the sum is equal to, this is 472 times 36 divided by 2 is 18. 472 times 18 gives us 8,496. Okay, so watch the video, pause it, take notes, practice the problems that I assigned, and send me questions.